Well, I was looking for a joke about statistics and tables, but I couldn't find one, but I did find one with a table in it, literally, a dining table. And this little family of division symbols is sitting around the dining table and they say, remainders again. You get it? Leftovers. Those are what you get with the remainder. Anyways, let's go ahead and look at contingency tables. So first of all, we're dealing with 743 adults who were asked if they smoked or not and their perception of the risk of smoking. I can look at the perceived risk here, which is the how harmful every one of these adults thought the smoking was, or the risk of smoking. And we can also look at smoking status, how many of them were smokers and how many are not. These are actually called marginal distributions because they provide information for totals for one type of variable. Now, a contingency table, you can see now I have it broken up into two categorical variables put together. So I'm taking the same data, but in more detail. And it shows how individuals are distributed along each variable, contingent on the value of the other. So the individuals who thought smoking was very harmful, depending if they were a smoker or a non-smoker, their smoking status. So let's go ahead and fill in this table. One important thing is that these rows across should add up to the totals we had before. Columns should add up to the totals that we had for smoking status. So doing that, I can actually figure out what these other values are. Now, if you look at this, remember I mentioned that before on the previous slide, or just higher up in your notes, you have a table that looks like this middle piece has been removed, and that's called the marginal distribution for perceived risk. So you're seeing how it breaks down on risk without regard to who's smoking. The marginal distribution for smoking status breaks it down according to status without regard to if they thought it was harmful or not. So we're going to look at an example. What percent of adults are smokers who perceive smoking as very harmful? So that means they're both a smoker and they thought it was very harmful. Well, your smokers are right here. And the people who thought it was very harmful are on this row, this purple row. Where they intersect, that's where both occur. So we have 145 of these people. And out of a total of 743. So we would just basically go 145 over 743, which is 0.195. Change that to percent, and it's 19.5%. Next question is, what percent of adults are non-smokers who perceive smoking as not at all harmful? Well, I'm looking only at non-smokers and also only at people who think it's not at all harmful. So those are 5 people. That's the top part of my fraction here. Then I need the total. It's the same total. 5 over 743, 0.0067 or 0.67%. Now we can look at perceived risk by smoking status. So what we're going to do is we're going to imagine making an individual distribution for each perceived risk. So here's one. We're going to make a distribution for this and look at it according to smoking status. So we can see on this row, 145 out of 577, or 25.1% of the people, of people who thought it was very harmful, were smokers. 75% of people who thought it was very harmful are non-smokers. So each risk should add up to 100%. So 72 divided by 122 is 59. That leaves 41%. 17 out of 42 is 53.1. And that leaves 46.9%. And then finally, 7 out of 12 is 58.3%. And that leaves 41.7%. So you can see each row adds up to 100%. Okay. Now we're going to, what percent of people who think smoking is not too harmful are also smokers? So people who think smoking is not too harmful, that's this group, are also smokers. So that would be 53.1. So because we said what percent of people who think smoking is not too harmful, so that's our world. All we're worried about is this area. So you want to go perceived risk by smoking status when you're only concerned about groups that think it's very harmful or think it's somewhat harmful or not too harmful, but these are not overlapping. You're only worrying about one type of these people. All right. So the percent of people who think smoking is not too harmful, who are also smokers, there are 53.1% of them. Okay, now we're going by smoking status. So instead of having these add up, my risks add up to 100%, I'm having my smoking status add up to 100%. So 145 over 241, that's over half at 60.2%. Then this works out to 29.9, 7.1, 2.9. And again, each status is going to add up to 100%. Continue the math on this side, and we get 100% here. So what percent of smokers, so we're looking at this, only smokers, these guys don't matter, think smoking is not too harmful? Only 7% of them. So that's the group in here, and I'm sorry, not at all harmful. Oops, cross that out. Then this is not too harmful would be 7.1%, not 2.1%. If they asked not at all harmful, then it would be the 2.9%. So conditional distribution of perceived risk. We've got these perceived risk, and that's on the condition of someone being a smoker. So this is a conditional distribution of perceived risk given that they're a smoker, and here it is given that they're a non-smoker. Does the data suggest an association between perceived risk and smoking status? And you can see a greater percentage of non-smokers see a higher risk in smoking. That kind of makes sense. And a smaller percentage of smokers consider it very harmful. So yes, smokers are less likely to perceive smoking as harmful. Now, you can also do pie charts of perceived risk, and that's frequently how you do it. Here it is for smokers and non-smokers. And you can see the very harmful slice here is much bigger for non-smokers than it is for smokers. So you can see visually that there's less perceived risk by smokers. So they think, oh, it's not going to be that bad, so it's okay if I smoke. Whereas non-smokers, they tend to think, oh, no, it's not very good at all, and I better not even try. One thing when you're doing your pie charts, make sure that these are data that add up to 100% and do not overlap.